You've heard Billie Eilish's song about it, but what actually is dark matter? Is it real, or are we just dumb? Now, this is an interesting question because there is no evidence that we are dumb. But if dark matter does exist, it makes up a whopping 80% of all matter in the universe. So it turns out we might be missing something big. And when I say big, I mean unimaginably huge. We can't see this stuff though, so how do we know it exists at all? Well, like most things in science, we infer the existence of dark matter from its effects. You see, back in the early 20th century, astronomers were studying how stars and galaxies rotate. And they noticed that the stars in these systems rotate way faster than they should. I mean, if you know how gravity works, then you probably already know why this is surprising. Every planet and star in a galaxy is attracted to the center of that galaxy, where the supermassive black hole resides. This gravitational attraction depends on the mass of the object and how far away it is. The further away it is, the weaker the gravitational pull. So, if you have a bunch of stuff in a galaxy, it pulls everything else towards the middle, which should make the outer parts of the galaxy rotate slowly. It's like when Isaac Newton made his famous discovery of gravity by watching an apple fall off a tree. We don't see the force of gravity, but we can observe its effect on other things, like apples falling or galaxies spinning. So, for astronomers to say that galaxies rotate too fast means that there has to be some extra force counteracting the gravitational pull of the black holes. But what could this force possibly be? Enter dark matter. This mysterious substance doesn't interact with regular matter or light, so it's invisible, but it would affect how fast things move around it. A lot like that time I tried to explain quantum mechanics to my mum over dinner. She didn't speak a word the entire time, but I could tell she was very moved by my brilliance. Okay, so if dark matter were to replace my mum in this analogy, then it would explain why galaxies rotate so fast. Now, scientists estimate that the total mass of all the dark matter in the universe is about 5 times greater than the mass of all the regular matter in the universe combined. That's a pretty big deal. Like, imagine you walk into a party and there are 10 people there. That's 100% of the people at the party. Then someone tells you that 90 of those people are secretly aliens, even though no one looks different. All of a sudden, your entire perception of the party has changed. And now you really nervous, because you do know how many tentacles someone could have before it's considered rude to ask them to leave. My point is that if 80% of something is completely different from what it seems, then that changes things. But just because we can't see dark matter doesn't mean it's not real. In fact, scientists have collected quite a bit of evidence to support its existence. For example, you've probably heard of gravitational lensing. This is when light gets bent by gravity. So if there's a massive object in space, like a galaxy cluster, its gravity will distort the light coming from objects behind it, making them look like giant cosmic funhouse mirrors. Scientists use this phenomenon to study things that are too far away to be seen otherwise. And while they've been doing this, they've discovered that these massive objects bend light more than they should. If there's more mass in a galaxy cluster, then it should have a stronger gravitational pull and thus bend light more. But observations suggest that it's bending light way more than expected. Again, this could be explained if there's some invisible mass contributing to the gravitational pull, aka dark matter. In addition to that, there's another astronomical observation that fits nicely with the idea of dark matter. About 20 years ago, two independent teams of astronomers were measuring the cosmic microwave background, or CMB. This is basically the leftover radiation from the Big Bang. Think of it like the static on your TV when there's nothing playing. These two teams were expecting to see the same thing, but they got different results. One team saw a pattern that matched the predictions of the Big Bang theory without any dark matter. The other team saw a pattern that matched the predictions of the Big Bang theory with dark matter. Now, normally, a difference like this would be cause for concern. You want your scientists to get the same results, especially when they're trying to figure out if there's invisible stuff in the universe. But in this case, it turned out to be an incredible stroke of luck because it forced scientists to re-examine their data and come to a consensus. They all agreed that the data fit the Big Bang theory with dark matter better than without. To be fair, it wasn't exactly a party, more like a funeral. But the three scientists who won the Nobel Prize for discovering this effect weren't sad at all. They were thrilled because it meant that their model of the universe went from this to this. Or if you prefer emojis, it went from this to this. Now, I know what you're thinking. Okay, Zach, you've convinced me that dark matter exists, but why do we need this mysterious stuff? Why can't gravity just do its thing? Well, that's a great question, but I'm afraid it'll take us several centuries to answer it. We're still working on it. What I can tell you is that there are several alternative theories to dark matter that try to explain the same observations without introducing this new substance. For example, there's modified gravity, which is the idea that gravity does unfollow the same rules on large scales as it does on small scales. Or maybe gravity gets weaker as the universe gets older. Or maybe the laws of gravity change near black holes. Now, it's very possible that one of these ideas is correct, but the problem is that each one of them requires us to modify Einstein's theory of general relativity, which is kind of a big deal. You see, Einstein's theory of general relativity is one of the two pillars of modern physics. The other pillar is quantum mechanics, which explains how the universe works at the atomic and subatomic level. General relativity is known to work extremely well for planets, stars, and galaxies. Quantum mechanics is known to work extremely well for atoms, photons, and cats. But the problem is that no one has figured out how to combine these two theories, which means we can't describe things that are both very big and very small, like, say, a quantum black hole. In other words, we can't describe the entire universe. This is why I think dark matter is worth pursuing, because if we can find it, then that'll be our first clue as to how to unify these two pillars of physics. And if we can do that, then that'll be the biggest scientific breakthrough since sliced bread. In fact, I'd argue that dark matter is the biggest scientific mystery of our time. It's bigger than the Higgs boson, bigger than the Large Hadron Collider, and even bigger than my ego. Now, I'm not saying it'll be easy to find dark matter. Particle physicists are currently building massive detectors deep underground in the hope of directly detecting it. But it's not like we'll be able to run these experiments on Earth. Scientists will have to build new instruments on other planets like Mars, Jupiter, and Titan. And I'm not kidding. This is literally the plot of a sci-fi movie I wrote and directed in college. Unfortunately, Hollywood passed on it. Look, the bottom line is this. We don't know if dark matter exists, but there's good evidence that it does. And if it does exist, then it makes up the majority of the matter in the universe. Personally, I think it's worth the effort to find something that might make up 80 of the universe, even if it means we'll have to go to space, or worse. Let James Corden host The Late Late Show. If you enjoyed this video, then you might enjoy my podcast where I talk about the most exciting discoveries in science and technology every week, and you can listen to it on various platforms. Thanks for watching.